A spacecraft drifts millions of kilometers through empty space. No road signs, no GPS towers, no one steering it by hand. Yet, at exactly the right moment, it fires its engines for just a few minutes and lands on a tiny planet that has been racing around the sun the entire time. How? Not luck, not magic, just mathematics. But here's the real mystery. How can symbols scribbled on paper predict the motion of worlds that don't even know we exist? Stickman couldn't stop thinking about that question. If mathematics is something humans invented, why does the universe seem to obey it so perfectly? Why does a formula written centuries ago still predict the path of a comet that nobody had ever seen? Determined to find out, Stickman packed nothing but a pencil and began searching for the universe's oldest language. His first clue wasn't hidden in a laboratory. It was hidden in a sunflower. At first, it looked ordinary. Hundreds of tiny seeds packed together in perfect spirals. Stickman counted one set of spirals, then the other. The numbers weren't random. 34, 35, sometimes 55 and 89. Again and again, the same numbers appeared. Why would a flower care about numbers? That wasn't even the strange part. The same pattern appeared in pine cones, pineapples, Romanesco broccoli, even the branches of certain trees. Different plants, different environments, the same mathematical fingerprint. Stickman suspected coincidence, so he searched somewhere completely different. The night sky. He watched planets orbit the sun. Their paths weren't wandering aimlessly. They followed predictable curves. Astronomers could calculate where Mars would appear months from now with astonishing accuracy. But how? The planets weren't reading equations. The equations were reading the planets. That idea completely flipped the mystery. Maybe mathematics wasn't telling the universe what to do. Maybe mathematics was describing what the universe was already doing. Stickman needed stronger evidence, so he dropped a ball. It fell. He dropped another. It fell exactly the same way. Again and again. Objects didn't choose new rules every morning. Nature behaved consistently. And whenever something behaves consistently, patterns begin to appear. Patterns become measurements. Measurements become equations. Mathematics wasn't replacing reality. It was translating it. Imagine listening to a song. You don't see sound waves, but they exist. A musician can write notes on paper, and another musician, thousands of kilometers away, can recreate the exact same melody. The notes aren't the music. They're a language describing the music. Mathematics works the same way. An equation isn't gravity. It describes gravity. A graph isn't motion. It describes motion. The symbols are not reality. They're an incredibly precise way of talking about reality. That solved one mystery, but created another. If mathematics is just a language, why is it so unbelievably powerful? Stickman walked into an imaginary library filled with shelves of equations. Some were thousands of years old. One dusty page described circles, another explained triangles, another contained strange symbols called calculus. The surprising part? Many of these ideas were discovered long before anyone knew what they'd eventually explain. Calculus was developed to understand motion and change. Centuries later, it became essential for building rockets. Complex numbers once seemed like meaningless imaginary inventions. Today, they're used in electrical engineering, quantum physics, and digital communication. Mathematicians kept discovering ideas that seemed useless, until the universe revealed where they belonged. It almost felt as though mathematics had been waiting patiently to be found. Stickman wondered whether mathematics was invented or discovered. Think about the number 3. 3 apples, 3 stars, 3 people. The apples can disappear, the stars can explode, the people can leave. But the idea of 3 remains exactly the same. It exists independently of the objects we use to represent it. That's why mathematicians across different civilizations often uncovered the same truths. Different languages, different cultures, same mathematics, because patterns don't belong to us. We notice them. The investigation was becoming clearer. Mathematics is the study of patterns. Whenever patterns repeat, mathematics follows. Day and night, the changing seasons, ocean tides, the rhythm of your heartbeat, the symmetry of a snowflake, the branching of rivers, the structure of crystals, the growth of populations, the spread of diseases, even the pixels on your phone screen. Everywhere Stickman looked, hidden patterns quietly connected things that seemed completely unrelated. Then he reached the biggest surprise of all. Your smartphone understands only two symbols, 0 and 1. That's it. Every photo you've ever taken, every video you've watched, every message you've sent, every game you've played, every song you've streamed, billions of colors, millions of sounds, entire movies, all reduced to enormous sequences of zeros and ones. Mathematics transforms incredibly complicated reality into simple rules that machines can understand. Without mathematics, computers wouldn't calculate, the internet wouldn't function, GPS couldn't locate you, artificial intelligence couldn't learn. Modern civilization would look completely different. Stickman smiled. The mystery wasn't limited to space or nature anymore. It was sitting in his pocket. Still, one final question remained. If mathematics explains so much, can it explain everything? Not quite. There are still unsolved problems that have challenged brilliant minds for decades. There are chaotic systems where tiny changes produce wildly different outcomes, making long-term prediction incredibly difficult. There are mysteries about the universe that mathematics is still helping us explore rather than fully answer, and that's exactly what makes it beautiful. Mathematics isn't a finished book, it's an unfinished investigation. Every generation solves a few pages and leaves new puzzles behind. Finally, Stickman looked back at the spacecraft that had started his journey. It hadn't reached its destination because someone guessed correctly. It arrived because the universe follows patterns that can be understood, tested, refined, and expressed through mathematics. That's why a bridge can stand, why an eclipse can be predicted years in advance, why engineers can build satellites, why doctors can analyze medical scans, why scientists can search for planets around distant stars. The universe isn't reading equations, but whenever it leaves behind a pattern, mathematics is the language that allows us to read it. And perhaps that's the greatest discovery of all. Mathematics isn't about memorizing formulas or surviving exams. It's about learning to notice the invisible patterns that have always been there, asking better questions, making logical connections, and slowly decoding a universe that never stops giving clues. The next time you see a spiral in a shell, a shadow moving across the ground, or the stars overhead, remember this investigation. You may not just be looking at nature, you may be looking at a sentence written in the oldest language the universe has ever spoken. And if you're wondering what other mathematical secrets are hiding in plain sight, our next investigation is already waiting.